Trained nurses almost gave lethal doses to patients because a voice on the phone told them to. Perfectly healthy people checked into mental hospitals and couldn't convince anyone that they were sane. And entire groups of galaxies are drifting in the same direction for no clear reason. These are experiments that produced results no one could explain. Back in 1966, a psychiatrist named Charles K. Hofling ran a test inside a real hospital without telling the nurses. Here's what he did. Nurses working the night shift got a phone call from a man saying he was a doctor. They didn't know him, and he wasn't even in the building. He told them to give a patient something called Astroton. Little did the nurses know this was a fictional medication. The fake bottle had been placed in a drawer, clearly labeled with a 10 milligram maximum daily dose. The dose the man on the phone gave them was double the safe limit. And on top of that, the hospital rules said you're not even supposed to take orders like that over the phone. Well, out of 22 nurses, 21 were about to give the dose. Some of them had picked up the medication and started heading toward the patient before the researchers stepped in to stop them. Afterward, when they talked to the nurses, a lot of them admitted they had their doubts. It didn't feel right, but they went along with it because the instruction came from someone they thought was a doctor. That's what made this so unsettling. These were trained professionals, people that you trust to make your safety a top priority, not go ahead with something their gut is telling them is wrong just because an authority figure told them to do so. In 1973, psychologist David Rosenhan wanted to see how easy it was to get labeled as mentally ill. So he and 7 other completely healthy people checked themselves into psychiatric hospitals across the US. They all said the same thing when they showed up. They were hearing voices. Every single one of them was admitted. As soon as they were inside, though, they stopped acting. No more fake symptoms. They told staff they felt fine and were acting totally normal. But instead of being released, they were diagnosed with serious conditions like schizophrenia, and they were kept there. The shortest stay was about a week. One of them didn't get out for nearly 2 months. While they were inside, they wrote down everything that they saw. Even that got twisted. One doctor noted that writing in a notebook was a sign of mental illness, calling it compulsive behavior. Eventually, they were let go, but only after agreeing that they had a disorder that was now in remission, not that they were never sick. Probably one of the strangest experiments that I've ever read about. Imagine you're using a straw to fire tiny paper spitballs at a wall with 2 vertical slits in it. Naturally, you'd expect the wads to pass through the slits and end up forming these 2 lines on the wall behind them. In the world of tiny particles like electrons, this is exactly what happens. Until you stop looking at them, that is. When scientists fire electrons at these 2 slits without any measuring device watching, the electrons don't form 2 lines. Instead, they create this wave-like interference pattern, almost like ripples in a pond overlapping. So the electrons somehow travel through both slits at the same time. When researchers tried to outsmart the particles, essentially by placing a detector by the slits to see which one the electron actually went through, things got even weirder. As soon as that detector was turned on, the electrons stopped acting like waves and went back to acting the way you'd expect, forming 2 simple lines. It was as if the particles knew they were being watched and changed their behavior to accommodate the observer. This seems to imply that the very act of looking at the world changes how physical reality functions, at least at the particle level. In the 60s, a Tanzanian student named Erasto Mpemba noticed something that seemed to break the laws of physics during a school cooking class. He was making ice cream and realized that his hot mixture actually froze faster than the mixtures his classmates had already cooled down. When he told his teacher about this, he was laughed at, but he eventually convinced a physics professor to run an experiment. The results were not what anyone was expecting. Under certain conditions, hot water freezes faster than cold water. This makes 0 sense on the surface. If you have a cup of water at 80 degrees, say, and a cup at 20 degrees, the hot cup has to pass through that 20-degree mark on its way to freezing, so logically, the cold cup should always have a head start. Scientists have spent decades trying to pin down a single reason for this, but none of their explanations fully work every time. Neutrinos are often called ghost particles because they're nearly weightless and can pass through solid lead like it's thin air. Because they're so hard to catch, scientists built massive experiments using a rare metal called gallium to detect them. 2 major projects, one in Russia and one in Italy, used huge tanks of this metal to count how many neutrinos were coming from the sun or radioactive sources. The math for these experiments was supposed to be rock solid. Based on everything we know about nuclear physics, researchers knew exactly how many neutrinos should be hitting that gallium, but every time they ran the test, they came up short. About 20 to 30% of the expected neutrinos just weren't there. This became known as the Gallium Anomaly. Scientists still can't say for sure why this happens. One of the leading theories is that some neutrinos are shape-shifting into a fourth type of particle called a sterile neutrino, which is so ghostly that our detectors can't see it at all. But if this is true, it's a whole other can of worms. It would mean there's a whole category of matter that we've been completely missing, and our standard model of the universe is also missing a huge piece of the puzzle. Muons are basically the heavier, more unstable cousins of the electron. They act like tiny spinning magnets. When you put them in a magnetic field, they wobble at a very specific rate. Because we understand electromagnetism so well, physicists calculated exactly how fast that wobble should be, down to many decimal points. To test this, Fermilab built a massive 50-foot wide magnetic ring and sent muons racing around it at nearly the speed of light. And something strange happened. The muons wobbled significantly faster than the calculations predicted. In the world of subatomic physics, significantly means like a tiny fraction of a percent, but that tiny gap is not as tiny as it seems. It means that the muon is being pushed or pulled by something that we haven't discovered yet. For centuries, ball lightning was treated like a myth, something sailors and farmers claimed to see, but scientists just wrote off as hallucinations. That changed in 2012 when a team of Chinese researchers was out in the field with high-speed cameras and spectrometers to study normal lightning. And by sheer luck, they captured a glowing sphere about 15 feet wide that appeared after a ground strike. It floated for several seconds, and then it vanished. They now had hard data. Ball lightning was real. The problem is that according to everything we know about plasma and electricity, ball lightning shouldn't exist. Normally, a ball of superheated gas should explode or dissipate in a fraction of a second, but this moved calmly across the ground. Even weirder, the sensors showed that the ball contained silicon, iron, and calcium, elements found in the dirt, meaning the lightning strike had somehow vaporized the soil and turned it into this floating, glowing orb of dirt gas. Scientists have tried to recreate this in labs using everything from microwave ovens to high voltage batteries, and while they can make tiny sparks that look similar, they can't make them last or behave like the ones seen in nature. According to the standard model of how the universe began, everything should be expanding outward at a fairly uniform way. While gravity pulls local things like galaxies together on a massive scale, things should be moving randomly. But when astrophysicists started studying the movement of giant galaxy clusters, they found that a huge number of these clusters, thousands of them, seem to be caught in this massive current. They're all drifting at incredible speeds toward a very specific small patch of space. But why? Well, they're not really sure. Some scientists have proposed the dark flow theory, and this theory basically puts forth that something massive, maybe even another universe, exists just beyond what we can see and is tugging on our galaxies with its own gravity. When we want to send a spacecraft to the outer planets, we often use Earth's gravity as a kind of slingshot to help it gain speed. The ship flies close to the Earth, gets a boost from our gravity, and zips off into deep space. The math for this is very precise, and we've been doing it for decades. But starting with the Galileo mission in 1990, engineers noticed something weird. The spacecraft moved away from Earth after its flyby. It was moving slightly faster than it was supposed to. The jump in speed is tiny, less than the speed of a crawling insect, but it is there and it's pretty consistent. It happened again with the Near spacecraft and the Rosetta probe. Scientists have looked into every possible normal cause. Could it be the Earth's atmosphere dragging on it? No. Could it be the pressure of sunlight? Apparently not. Could it be Earth's magnetic field? And still no. To this day, we don't have a confirmed reason for why this happens. In the 70s, NASA launched Pioneer 10 and 11 to explore the outer solar system. As they moved past Saturn and headed into the dark void of deep space, navigators noticed that the ships weren't exactly where they were supposed to be. They were off by a few thousand miles. Turned out that both ships were experiencing this tiny, constant pull back toward the sun. It was as if something invisible was dragging on them, slowing them down ever so slightly. For over 30 years, this was the great mystery of space travel. Eventually, a team of researchers spent years digitizing old records, and they concluded that the heat from the spacecraft's own batteries was bouncing off the back of the antenna, acting like a tiny thruster, pushing the ship backward. This is the most accepted answer, but a lot of scientists aren't fully convinced. They argue that the math doesn't quite add up. So there's still some mystery there. But with all that said, that's been the video, and I will catch you, yes, you specifically, in the next one.